In this session, we will discuss about sinusoidal response of an RL circuit. Consider a series RL circuit which is shown in the figure, and in this circuit there is a switch S, and it is indicated that now the switch is opened and the switch will close at a particular time. Let the time be t equal to 0. That means at t equal to 0 the switch S will close. When switch S is closed, the circuit is a continuous or circuit forms a loop, so that whatever voltage is applied here, that will go to this path. Okay, here at t equal to 0, that means the switch is closed and the applied voltage V cos omega t plus theta will flows through this circuit. Due to this applied voltage, a current I is flowing through the circuit, that is indicated here. So we want to find out the value of this current I due to this applied voltage V cos omega t plus theta. Here this is a sinusoidal voltage applying here. So we will have a look at this circuit and we can apply the KVL to the closed loop, which is containing resistance R and L, which are in series. So when we are applying the KVL, we know that applied voltage will be equal to sum of the voltage drop across each component in the circuit. So we can write applied voltage is V cos omega t plus theta, and voltage drop across resistance is R into I, and voltage drop across inductance is L into di by dt. This is the basic equation. So we can rearrange this equation. See, here in the di by dt there is an L. We can divide the entire equation by using L. So we will get di by dt is equal to, di by dt plus R by L into I equal to V by L into cos omega t plus theta. See, this is a differential equation and this is of the form we can write it as d plus, here d by dt is indicated by d, and plus R by L into I. I is the unknown quantity that we have to find it out. That is the current. This is the current I which we have to find it out. So the equation corresponding to this circuit, series RL circuit with the sinusoidal input is d plus R by L into I equal to V by L into cos omega t plus theta. This is the equation. So you might have studied in the mathematics for the solution of this type of equation, that is the differential equation solution. So this will have two parts. First one is a complementary part or complementary function and a particular integral or particular solution. See, so this solution of this type of equation or this type of differential equation will contains two parts, particular solution and a complementary function, and the complementary function we can simply written as IC equal to C into e raised to minus t into R by L, that we have studied in the previous classes where we have analyzed the series RLC circuit. The particular complementary function is IC is equal to C into e raised to minus t into R by L. So you should by heart this equation for this type of series RL circuit with sinusoidal input. The complementary function is IC equal to C into e raised to minus t into R by L. So this is one part of the solution for I, and there is another part which is particular solution that we have to find out. That is, particular function of particular solution can be written as IP equal to, which will be in the form A cos omega t plus theta plus B sin omega t plus theta. And for the analysis purpose we need the first derivative of this IP. So we will write it as IP dash equal to, the first derivative of cos omega t plus theta is minus sin omega t plus theta. So there is a minus sign, minus A omega sin omega t plus theta plus derivative of sin omega t plus theta is cos omega t plus theta, and also an omega comes here, so b omega cos omega t plus theta. So this is the first derivative. See, these two equations we can substitute for the case of, that means equation 11.20 and equation 11.21 can be substituted in equation 11.18. that is equation 11.18 is this one, that is d plus R by L into I plus V by L into cos omega t plus theta. Here instead of I, see, you know that this is di by dt, this is first derivative. So instead of I, we can written it as a IP dash. Similarly, instead of I, we can write a cos omega t plus B sin omega t plus theta. So in 11.18 we have to substitute this equation. So we can substitute there, like we know that first derivative is this one, for instead of di by dt minus a omega sin omega t plus theta plus b omega cos omega t plus theta comes, and there is an r by l into I term. Instead of I, the term, this one will come, that is a cos omega t plus theta plus b sin omega t plus theta. That means these two equations are substituted in this equation or in this equation, whatever be the equations, and we are substituting here. So we will get a form like this, and in this equation we have to take the common terms outside. See, you know that in the first case sin omega t plus theta, there are common terms which containing sin omega t plus theta, also common terms which containing cos omega t plus theta. So when we are taking the common terms sin omega t plus theta, in the bracket minus a omega plus br by l will comes. Similarly, cos omega t plus theta can be taken outside, so in the bracket b omega plus ar by l will come. This can be obtained from the previous equation. There is a simple mathematical procedure, and that will be equal to v by l into cos omega t plus theta. Here, for easier solution, we have to compare the quotients of cos omega terms and sin omega terms. So when we are comparing the sin omega t plus theta terms, you know that in the left side, sin omega t plus theta term is this, minus a omega plus br divided by l. And in the right side, there is no such term, so we are equating it to 0. And similarly, we can compare cos omega t plus theta terms. In the left side, b omega plus ar by l comes, and in the right side, v by l comes. So we can equate these two. And from these two equations, we want to find out what is the value of a and what is the value of b. See, minus a omega plus br by l equal to 0, we can rearrange this equation as a omega equal to br by l. In this case, a can be written as br divided by l omega. So once we get b value, we can simply find out a. So similarly, we have another equation, that is b omega plus ar by l equal to v by l. So when we are rearranging this equation, we know that b omega equal to v by l minus ar by l. Here we can substitute. See, here b will be equal to, b omega will comes to the denominator side, that is v by l omega minus ar by l omega. In this equation, we can substitute equation 2. This one is relating the equation a and b. This one relates a and b. So we can substitute for a in this equation 3. So that means equation 2 can be substituted in equation 3. So we will get b equal to v by l omega into v by l omega minus, instead of a, we can write this equation, that is br by l omega, that is equal to br by l omega into r by l omega. So we will get the equation for b by rearranging these equations. Here b, there is a b term, so we can take this term into left side. So this will gives the equation like this, that is b plus br square by l square omega square equal to v by l omega. In this, b can be taken outside, so we will get this term. So by rearranging this equation, we will get b will be equal to v omega into l by l square omega square plus r square. So this is a equation for b. Once we get b, we can find the value of a by using this equation. So instead of b, we can substitute this value. We will get the value of a as vr by r square plus l omega all square. So we got the value of a and b. So we can substitute the values of a and b in the equation for particular function ip. So we will get ip dash will be equal to, we know that ip dash has got an equation. See, what is the equation for ip dash? Ip dash equal to minus a omega sin omega t plus theta plus b omega cos omega t plus theta. Here instead of a and b, we can write the values that we have find out now. So we will get the equation for ip dash as v into r by r square plus l omega all square cos omega t plus theta plus v into l omega divided by r square plus l omega all square into sin omega t plus theta. This is a lengthier equation, so in order to simplify it, we are making some substitutions such as m cos phi equal to this term, that is vr by r square plus l omega all square. Similarly, m sin phi equal to this term. So m sin phi equal to this term, v into l omega by r square plus. Here we can write that to find the m and phi value, we can simply making a division, that is m cos phi by m sin phi by m cos phi equal to tan phi, that is equal to when we are dividing these two quantities, we will get L omega by R. So tan phi is equal to L omega by R. So we can write phi equal to tan inverse L omega by R. That you should remember that equation, that is phi equal to tan inverse L omega by R. Similarly, we can, if we are taking the square of these two equations, that is m square cos square phi, that will give a square of this value. Similarly, m square sin square phi will give the square of this value. So when these two quantities are added, m square cos square phi plus m square sin square phi will be equal to v square r square divided by r square plus L omega whole square. That will be taking whole square plus v square omega square L square divided by r square plus L omega whole square. That will be taking as the whole square. So we know that when we are taking m square outside, we know that the relationship cos square phi plus sin square phi will be 1. So we will get the equation like m square equal to, in this common terms can be taken outside. So v square by r square plus L omega whole square can be taken outside. So inside the bracket this quantity will be there, and these two terms can be cancelled out. So we will get m square will be equal to v square divided by r square plus L omega whole square. So m can be written as v divided by square root r square plus L omega whole square. See, we know that IP has got the equation. We know that IP has got the equation as IP dash is equal to m cos phi into cos omega t plus theta, and instead of this m sin phi into sin omega t plus theta. That is the IP dash. In that case, we can substitute for m. That means IP is m cos phi into cos omega t plus theta plus m sin phi into sin omega t plus theta. So we can write, you know that this is in the form of cos A cos B plus sin A sin B. So it can be written as cos of A minus B. That is a basic formula for mathematical formula. That is m equal to, so we can write it, if it is A and it is B, then we can write a cos omega t plus theta minus phi. That will be equal to IP equal to m into cos omega t plus theta minus, instead of phi we can write, we know that phi is tan inverse omega L omega by R. So we can write IP equal to v divided by r square plus L omega whole square into cos omega t plus theta minus tan inverse L omega by R. So we got the value of IP. So the complete solution for the current, we know that first we said that the current has got two parts, that is complementary part and a particular function. Complementary function is IC and particular function is IP. Complementary function is C e raised to minus t r by L, and particular function is, now we find out it as v by square root r square plus L omega whole square into cos omega t plus theta minus tan inverse omega L omega by R. This is a very important equation. You should remember this equation and you should by heart it, because for doing problems this will be very useful. And in this case you can see that there is a constant C. So we have to find this constant value C. For that we are taking the initial conditions. You know that this is an RL circuit. At t equal to 0 switch is closed. So when the t is equal to 0, switch will be closed and current will flow through the circuit. But you know that inductor has a property, it will not allow the sudden changes in the current. So at t equal to 0, the switch is closed. We expect that there will be a current flow through the circuit, but actually there will not be any flow of current because the property of the inductance. So we know that, so we can say that at the instant t equal to 0, current will be 0. So that is an important thing in the case of a circuit containing inductance. At particular time t equal to 0, when the switch is closed, there will not be any current due to the property of inductance. It will not allow the sudden changes in the current. That is why the current will be equal to 0. So we can substitute that conditions. That means at t equal to 0, current will be equal to 0. So 0 will be equal to C into e raised to, instead of t we can substitute 0. So e raised to 0 quantity is 1. So there will be a C itself. And similarly here the t, there is a term t. So instead of omega t there is 0 comes. So 0 plus this quantity. So 0 equal to C plus this whole quantity without this omega t. So C can be written as C equal to minus V by R square plus L omega whole square into cos. You know that this term is not there because it will become 0 when we are substituting for t equal to 0. So inside the bracket theta minus tan inverse L omega by R comes. So this is also important. So you should by heart this C equation also. So we can write the complete solution as I equal to e raised to minus R by L into T into minus V. This is C, instead of C we can write minus V square root R square plus L omega all square into cos theta minus tan inverse L omega by R plus V by R square plus L omega all square into cos omega T plus theta minus tan inverse omega L into R. So for RL circuit which has a sinusoidal input, the solution of the current is like this. So you should remember that in this e raised to minus R by L into T is the C into e raised to minus R by L into T is the complementary function, and particular solution is this one. And in order to, so first if you want to find out the current, you have to write this equation, and for finding the C you have to substitute the initial condition. So next we can do a problem. So in the circuit shown in figure, determine the complete solution for the current when the switch S is closed at t equal to 0. Applied voltage is V by T equal to 100 cos 1000 T plus pi by 2. Resistance R equal to 20 ohm and inductance L equal to 0.1 Henry. So this is the circuit that contains the resistance value R equal to 20 ohm and inductance value is 0.1 Henry. And here the voltage, applied voltage is 100 cos 1000 T plus pi by 2. So I of T is the current. So this is a simple circuit and we can start doing problem by writing the KVL equation. So at T, we are assuming that at T equal to 0 switch will close and there will be a current flow. And we can write the KVL equation as, you know that, how can you write the KVL equation? You know that total voltage is equal to voltage drop across this one and voltage drop across this one. So voltage drop across 20 ohm is 20 into I. Voltage drop across 0.5 is 0.1 into di by dt. That will be equal to this applied voltage. So first equation is 20 into I plus 0.1 di by dt equal to 100 cos 1000 t plus pi by 2. And in this equation we can write the di by dt in terms of di by dt. So we have to divide the entire equation by 0.1. So di by dt plus 200 I equal to 1000 cos 1000 t plus pi by 2. And this can be written as the form d plus 200 into I equal to 1000 into cos 1000 t plus pi by 2. And this equation has two parts of solution. First one is complementary function. Second one is particular integral. So you should remember the complementary function. That will be IC equal to C into e raised to minus t into R by L, where R by L is R is 20 and L is 0.1. So R by L equal to 200 t. And particular solution will be of the form A cos omega t plus theta plus B sin t omega t plus theta. But we know its equation as IP is equal to, you should by heart that equation, that is IP will be equal to V by square root R square plus L omega all square into cos omega t plus theta minus tan inverse omega L by R. So you should by heart this equation. This is the form of the particular solution. And here omega equal to 1000, we know that it from the input, and V is 100, that is the maximum amplitude, and theta is pi by 2, that is also given in the that is also given in the supply voltage, that is 1000 t plus pi by 2. Also L is 0.1 and R is equal to 20. We can substitute these values in the particular solution. So we will get the IP value as IP will be equal to 100 divided by 1.9 into cos of this term. So we will get IP equal to 0.98 into cos 1000 t plus pi by 2 minus 78.6. So we got two values, that is we got the values of IP and we got the values of IC. So complete solution of I will be equal to IC plus IP. IC is C into e raised to minus 200 t and IP is this term. Here you know that there is an unknown quantity C. You have to find out the value of C by applying the initial condition. You know that in this case at t equal to 0, current will be equal to 0 due to the property of inductance. So we can simply substitute C is equal to, C will be equal to minus 0.98 into cos pi by 2 minus 78.6. This is obtained from this equation. You know that C value will be equal to minus V by R square plus L omega all square into cos theta minus tan inverse omega L by R. Here you know that theta is equal to pi by 2 and omega L by R we can substitute omega value, L and R value, and instead of V value also we can substitute. So we will get the value of C as, you know that C will be equal to minus 0.98 into cos pi by 2 minus 78.6. That means this is the value of IP. In this case, IP will be obtained by, in this case, when t equal to 0, we will get a minus 0.98 into cos pi by 2 minus 78.6. So we got the value of C. Once we got the value of C, we can substitute the value of C in this equation. So we will get a total solution for the current I will be equal to minus 0.98 into cos pi by 2 minus 78.6 into e raised to minus 200t plus, you know that particular solution will be this one. So we can write it as 0.98 into cos 1000t plus pi by 2 minus 78.6. So this is the complete solution for the current. So in order to do problem, you should by heart some of the equations for total current I, complementary solution IC, and particular solution IP, and also the equation for finding the value of C. These are the quantities you have to by heart. Okay, that's all about this topic. Thank you.